The figure shows the circuit diagram of a center tap full wave rectifier. So in the figure you can see a transformer, two diodes and a load resistance. As usual, the transformer is used to reduce the power supply or to increase the voltage of the power supply or AC supply that we are applying at the primary of the transformer. If you are using line voltage, we have to step down it, or if you are using some other small AC supply voltage, you have to step up it. For that we are using this transformer. Transformer will either step down or step up the voltage that we are giving at the primary of the transformer. The two diodes are there. In the half wave rectifier we have only one diode. In full wave rectifier we have two diodes, and we have a center tap connection. What do you mean by center tap? It is an additional wire that is connecting at the exact center of the secondary winding of the transformer, and this connection divides the secondary voltage into two equal halves, one positive voltage and another one negative voltage, and the total voltage will be the sum of the total voltage of the secondary winding will be the sum of the positive voltage as well as the negative voltage. And here the two diodes are used for the rectifying action. But during the positive half cycle of the input AC, and A becomes positive and B becomes negative, diode D1 will be in forward bias and diode D2 will be in reverse bias, and we will be getting an output at the load resistance RL. And during the negative half cycle, this end A becomes negative and end B becomes positive. Then diode D2 becomes forward biased and D1 becomes reverse biased. This time also you will be getting a resistance voltage across the load resistance. So in this case, in both cycles of input AC, we are getting an output at the load resistance. That means this rectifier is a full wave rectifier, and if you notice the voltage across the RL, it is in the same direction. That means we get a DC voltage across the load resistance.